Here we're at problem 4F from our 1.3 set of notes. We see that we have the limit as x approaches 0 of this rational function. We notice a little bit of trig going on. So if we were to try going ahead and using that direct evaluation, we'd end up with the cosine of 0. Well, the cosine of 0 is 1 minus 1. So we would end up with a 0 on top. That can happen. We can have 0 on top. But when we go ahead and throw it in the bottom, that x value is 0, we see that we end up with the sine of 0. Well, that's 0. 0 squared is 0. So we end up with 0 over 0, that indeterminate form, which we know is an issue. And unfortunately, that's not going to be able to help us out. Another option that we have is going ahead and maybe factoring to see if something can cancel. Unfortunately, there's nothing really here that looks like it can cancel. However, there is one thing though that we can go ahead and rewrite, especially like this sine squared of x. We can go ahead and rewrite that as 1 minus cosine squared of x. So then we end up with the limit as x approaches 0 of our cosine of x minus 1 on top, all over. Again, we end up with 1 minus cosine squared of x on the bottom. Well, on the bottom, that's actually, believe it or not, the difference of two perfect squares, so we can go ahead and actually factor this guy. So we end up with the limit as x approaches 0 of the cosine of x minus 1 on top still, all over 1 plus cosine of x times 1 minus cosine of x. And these two really look similar, and they're very close to being exactly the same. However, all we have to really do is go ahead and factor a negative 1. And it really doesn't matter if we factor it out of the top or the bottom, again, just because that negative can be applied to the top or the bottom. It doesn't really matter. So let's go ahead and we'll just go ahead and factor a negative out of the top one. So we have the limit as x approaches 0 still of negative cosine of x plus 1. So again, because we factored a negative out, our end result would be negative cosine of x plus 1. We end up then with that negative outside. I'm going to go ahead and just flip-flop the order of this. So we end up then with 1 minus cosine of x. And on the bottom, we have that 1 plus cosine of x times 1 minus cosine of x. And now they can end up canceling out with one another. So then we end up with the limit as x approaches 0 of the only thing that's left on top is that negative 1. On the bottom we have this 1 plus cosine of x. And at this point, now we can go ahead and plug in our value. So when we use our direct evaluation, we end up with negative 1 still on top over the cosine of x, or I'm sorry, the cosine of 0 is 1. So we have 1 plus 1 is just 2. So our limit just comes out to be negative 1/2. So again, that is example 4F from our 1.3 set of notes.